So I did look over the exit ticket check-in yesterday, and we were probably roughly at like a 50% class-wide. So there were two problems, one like the top one, and then one that had some fractions in it. Kinda like the bottom one, except for it was an equation and an inequality. So I need you to get help if you're struggling. Like if you know you got one or both of those wrong yesterday, you're in a place where you need to start asking for help. Okay? I'll keep putting stuff in front of you, and obviously we'll review as we go, but at some point, if it's just not clicking, you gotta come get that individual help. Please come do that. These kind of problems will be on an assessment here in the future, and so if you got both of those wrong yesterday, that would kind of reflect how it's planning to go at this point on this assessment, okay? Unless you do something different. So hopefully as we do more, it will get better, but we also need to make sure that you're getting help. Okay, so get rid of parentheses by distributing. Be careful with your like terms and your signs, all that. And now we need to combine our y's on one side of the equation. It doesn't matter which side you pick. I personally recommend to make the y or variable positive. So for me, that would be to move it to the left in this case. So that we have positive 3y. And then now we need to get rid of this 22 and get that y by itself. So 3y equals negative 15, and then of course divide to get negative 3. Sorry, negative 5. Okay. Raise your hand if you got it. So it's the majority of you. Those of you who didn't, maybe come ask me at lunch today, and let's figure out a strategy, or maybe try to address the errors that you're making to help this go better. I will tell you where we're headed is solving systems of equations. In fact, let me show you real quick, just a quick preview. This is going to be a little ways down the road. Make sure I can get back here. So, do you remember these kind? Like this is a system of two equations where we're solving for both x and y. That's an algebra 1 thing. This one particularly says substitution, but we'll also talk elimination where we stack them and like subtract, okay? So that's an algebra 1 thing. The algebra 2 level takes us here. So obviously we'll review, but this is an algebra 2 level problem where we have 3 variables, 3 equations, and the workload is about 3 times as much, maybe at least. So again, that all involves solving. So if your skills in solving these basic ones like we just did are still struggling, these ones are tough. So they don't have to be tough. I'm saying if you're struggling with the basics, they're tough. So again, please get help. Guys, algebra 2 will run you over if you don't address issues right away. Okay, this is what we talked about yesterday, just a kind of a basic little equation, well, excuse me, inequality, but it has fractions. So how do we deal with that? Even though it's an inequality, it doesn't change our strategy when we see fractions.
I multiplied the whole thing by 12 over 1.
Perfect. Okay, so he says, I don't want fractions in here, let's get rid of them. So I see that 4 and 12 share a common multiple of 12. So let's multiply, and he said 12 over 1, which is fine, or just 12. Okay, and then I told you divide first, so 12 divided by 4 times negative 9. That's this first side. 12 divided by 4 is 3, times negative 9 is negative 27. Okay, so 12 divided by 4 is 3 times negative 9. That's this. And then over here, 12 divided by 12 times negative 5 well, that's of course 1 and then negative 5. So this just becomes negative 5. Okay. Now what? Yeah, so just divide both sides by negative 27. And we are going to leave this as 5/27 because it's totally fine to do that, and it's not necessary to make it a decimal. Okay? In most cases. But why did I leave it blank in between? Did I just forget to write the inequality? Or what do we need to remember about inequalities? CJ?
The inequality symbol switches when you divide or multiply by a negative.
Perfect. So we need to switch that thing around. So now it's less than, x is less than or equal to 5/27. Because again, we divided by a negative. The word by there is why we had to do that. Divide by a negative, switch. That says switch. Making up words as we go. Okay. What if this 27 had been positive and that 5 is negative? Would we have had to switch the inequality? No, because the 5 being negative isn't the issue, it's the 27. Because that's what changes the sign of things. Okay. How'd you do on that one? Raise your hand if you got it. Oh, hold on. I forgot we have to graph it. So stick this on here, 5/27. That is greater than 0. I don't know why I did a dot. Hold on. What's the approximate value of 5/27? Decimal lines. Approximately. What if it was 5/25? That's a fifth. What's the decimal value of a fifth? 0.2, right? So we're like just stuck right close to 0. Okay, and then which way does this arrow point, and should it be open or closed? Should be closed because it's or equal to. And what does this say? Let's just read it first. X is less than. Where are the numbers less than 5/27? On the number line, everybody point left or right. Okay. So there's your graph of the solution. Now raise your hand if you got it right. Sweet. Good job, guys. Awesome. So you had something like this on your homework from last night. Like one step, maybe actually looks like some 2-step equation inequalities, and then some other steps. One thing to keep in mind is like 17, 19. That's helping you practice solving equations as well, isn't it? We just have to be careful to look for the symbol switch and the graphing. So you got some more practice with those. How'd those go? Any of them you'd like to do? Or like needs to be running? Any questions on any of them? So I would say unless you're getting them all correct, or perhaps you just made a sign error here and you know what was wrong, you should be asking for the ones that you didn't get right. Okay? Again, unless you're 100% sure why that happened. Let's check.
Can you go over 324?
Yeah. 24. Did I assign that one?
Yeah, you did 313 and 327. But odd.
But let's do it anyway. 24. Okay? It's good review and everybody can benefit from seeing that. That's the one you asked about, right?
Yeah.
Okay.
Because on Google Classroom it said 313 to 327.
Odd. I think I typed odd after that.
Yeah.
Okay. But again, I think it's fine that we're doing it. And a little extra practice is okay. Unfortunately, took the time. Okay, I see fractions, which means I see denominators, which means I want to get rid of them, especially in something like this where they're scattered throughout. So what's a good number to multiply by to get rid of this? Yeah, 6. 3, 2, and 6 all go into 6. And we're going to distribute there there, just on the 1/2, and on the 1/6, not on the parentheses inside, the stuff inside. Okay, again, so 6 divided by 3 times 2g. So 6 divided by 3 is 2, times 2 is 4g. Okay, over here, we can probably do half of 6 without this process. That's just 3. And then 6/6 is just 1. So you don't need the parentheses because it's just 1 that you're distributing. Alright, so fractions are gone. Distribute that. 4g minus 3g. Is anybody thinking phone stuff? Connectivity? For some reason it's ringing in my head. 4g, 5g. Alright, 4g minus 3g is just g. Interesting result here. What do you notice? It should look kind of funny. Yeah, bring them up.
There's the real answer.
Yeah, because this is, well, there is an answer
Right.
because we have the or equal to, but a lot of the answers are not true. G plus 42 can't be less than itself, right? It could be equal to itself, but not less than, right? So if we finish solving, we're going to have, like, let's just real quickly show this step. It would be this. 0 is less than or equal to 0. Is that true? Is that a true statement?
Yeah.
Only because of that or equal to part. If it was strictly an inequality where it didn't have that, you know, if it was just less than, then we would have to say no solution. But because that or equal to part is there, we're good. Did that help? Jada, did that help? Good one. I'm glad you asked about that. Okay. Anything else you'd like to ask about on the homework? Are you feeling better about getting rid of fractions by multiplying by the common denominator? Okay. I definitely think that's helpful. Yesterday we started talking about interval notation, so grab your notes and let's get back into that, because the directions for these problems did say to write your answers in interval notation, but we haven't got there yet, so, and that's fine. No, that's not you guys. I kind of introduced it here before we left, and we saw that we're going to be using parentheses or brackets to show whether or not the endpoint is included in the interval or not. It does look kind of funny, to be honest, sometimes when we mix the two, but you get used to it. Alright, so interval notation is a method to show a starting to an ending value, which is an interval. Succinctly, that word means in a short, efficient way. So we're not writing it all out in a big, long way. Okay, here's what we do. Let's go into the symbols of it. So when endpoints are included. So think the or equal to version. So greater than or equal to or less than or equal to. So when the endpoints are included, use a bracket. So square it off. In the past, sometimes students will make their parentheses kind of square looking or their brackets kind of rounded looking, and it's like, well, which is it? So be specific, make sure that you can tell which is which. Okay, when endpoints are included, so if it has the or equal to part, if it's a closed circle on a graph, in fact, let's write that. Or closed circle on a graph. Okay. Right. Which kind of leaves us to understand that if the endpoint is not included, we'll use parentheses. So this would be strictly greater than, less than, or open circle on a graph. Use parentheses. Is that a weird word? I think that's a weird word. Okay. And of course we'll do examples. Never fear. We'll get you set up on this. Okay. We call, well, let me talk about that in a second. Here's a couple, like always the same. Negative, well, let's just say it this way. Infinity, we said this yesterday, is always a parenthesis. I don't know. Is that the right spelling? Parenthesis?
I was thinking about that earlier. I have
A
no
single
idea.
we've never
I
you
didn't know
don't
if
say
it was
parenthesis.
SES or what.
Parentheses single one. I don't know. Let's just go with it. That's funny. I don't know if I've ever thought of that before. Anyway, it's always a parenthesis because we can't reach infinity. We said that yesterday. I think Alex said that yesterday maybe. Right? I think it was you. You never get there. You get there, you get really far out there, and then you're like, wait, infinity means keep going. So put a parenthesis on infinities, always. Okay, another thing about infinity is its position. Because it's always going to be the biggest or always the smallest, right? So let's talk about how intervals are set up. I'm going to write it as this. Interval structure. I'm going to use parentheses, but that's just for now. It's not like it's always this way, but this is always going to be the smaller number and then the bigger number. Okay, so we're going to start and end. So start point, end point. Guys, I know this sounds so basic and makes sense, but for some reason students mess this up every year. They see an interval and they write it backwards. So here's what I was saying about infinity. If we always set it up this way, small number, big number, will infinity ever go right here? Can infinity ever be the smaller number? No. Will negative infinity ever go right here? No. But people do that. And so you got to make sure that your small number, big number, don't get that mixed up. I think sometimes people read it backwards and put it in here backwards. So maybe just a caution out here to the side. Always read a graph. And not everything we do absolutely will be on a graph, but from left to right. So I think that could be part of it. They see us, read it as a start value and read it and then write their interval backwards or something, but. So if you have positive infinity, it's always going to go on the right. If you have negative infinity, always on the left. Okay? We will use interval notation for the next 6 months. Every unit. So this is a big deal. I do want you to go home and study this and make sure it gets locked in. We're going to do practice, so that will help. But just in terms of concept, read these cautions and make sure that you don't get them mixed up. Let's go look at a couple things. Are we ready for that? Okay. So here's some. You don't have to copy this. Let's just use it to think. So I have 2 brackets and then 3 to 4. So interpret what it says. In set notation, this is what it would look like. We're not going to do much with that, but just if it helps you reference. So how would we say this first one? You want me to do this one for you so you kind of know where we're going? Okay. Well, does it include 3? Yes, bracket, right? Does it include 4? Yes. So this is all numbers from 3 to 4. Okay? How many is that? That's infinite. Even though it's only 1, it's infinite different numbers in there, right? Okay? How about this one? You guys try now. This is parenthesis bracket in case you can't see it well. Yeah.
All numbers 3 to 4 except for 3.
Okay. All numbers 3 to 4 except 3. How close to 3 can we get?
Very close.
Infinitely close. Like 3.000, 100,000 zeros and then a 1 or something. I mean, it just doesn't include 3. Okay, how about this next one?
All numbers from 3 to 4 but 4.
Okay. Good. Next one. This one's easier to say. Yeah, Anthony.
All the numbers between 3 and 4.
Good. All numbers between, now we can use that word, 3 and 4. How many is that? Still infinite. Now we have, if you can't see that, that is an infinity. Infinity has a parenthesis. And what does this tell us about the 3? Including 3. So how could we say this? Joaquin, how about you? How would you say that one?
Let's say, you can't see. Is that 3 and an X?
It looks like an X, but it's infinity.
Oh, well, then I would say 3 to infinity.
Okay? If we, yes, you're right. All numbers 3 and above, we could say it informally. But you're right, 3 to infinity. Okay, there's our first look at negative infinity. You just put a negative sign out in front of infinity. And so this would be all numbers what? Below up to 3, right? So we could say it shorter, maybe all numbers up to 3. And then how about that one?
All possible numbers.
All numbers, right? Okay? All real numbers. Let's put that in front of that. All real numbers. This class this is the class you finally get to talk about imaginary numbers. We will do that next chapter, next unit. Okay? So we do need to say real numbers in this class because there are imaginary ones. And if you want, there is a symbol for this in math. It's like an R, a capital R with this extra line. And that's the same as negative infinity to positive infinity, all real numbers. If you want to use that, I'm happy for you to do that. Okay, so that was interpreting interval notation, which is a good start. But we also need to be able to write it in terms of when we solve something. So, like back to our warm-up problem. That was the check problem. There it is. How would we write this solution in interval notation? So don't shout it out, but raise your hand when you have an idea of how to write that in interval notation. Okay. Got 3 hands right now. And maybe you can say it to yourself first, like all numbers blank, and then start thinking about how that looks as an interval. Good, getting some more hands, like 6 or 7, let's get some more. Casey, you got an idea? Right. Here's what this arrow means. It means even though the arrow points left, remember we start at negative infinity. We don't start at 5/27, right? And I think this is where students get mixed up. They read it as, oh, I'm starting here and going left. But that would have you do it this way. And is that okay? No, negative infinity is the smallest concept, so we can't put it on the right since the right side is the bigger number. So here's your numbers, but what goes on the sides? Is it brackets, parentheses, mixture, etc.? Spencer, how about you? Okay, what goes on infinity? Everybody always parentheses, right? And on the 5/27, it's a closed circle, so that is a bracket. So there's our interval for that problem. Okay? Okay, here's what I want you to do. I'm going to get rid of that. You're going to solve these and write their solutions in interval notation. So let me make those bigger. And I need to add that direction on here. Solve graph and write in interval notation. So let's take roughly, it's 9:23, so let's try to finish this up in the next 7 or 8 minutes. And then we can check. Any questions on the first one? How'd the interval notation go for it? Okay. Alright, you guys, if you're still working on this last one, keep working and I'll put this one up here. Very similar problem. So. How about that one? Again, it's helping you with solving, like just keeping that solving linear stuff in front of you. But now we're just adding the caution about when to switch the inequality and also the graphing and interval notation. This one is kind of interesting. Your common denominator is 56, so you could multiply by 56. And then you'll get 7. It'll be 7 times negative 21y. And over here, negative 30. 30, not 36. Okay, and then this is negative 147. And I'm about to divide by a negative, so what does that mean? Yep, switch that inequality around. And we're just going to leave this as 30 over 147, which is roughly a fifth. Again, it's roughly 0.2. So on a number line, it's just right there next to 0. And we switch this. I forgot to. I said it and didn't do it. So now it's greater than, and it's filled in to the right. So in terms of interval notation, what needs to go on 31/47? Bracket. Okay. I'm gonna put some more problems on Google Classroom. Please check. You're good, but tomorrow I don't have you because we have blocks, so I won't see you till Thursday. Thursday you're gonna be doing your NWEA test. So bring your Chromebook charged up and ready to go. Have your homework uploaded by Thursday. I'll change the date till then.